Hello, my name is Zach Gibbs, and I'm a content developer within Education Services inside Juniper Networks. And today we will be discussing the configuring AF interfaces with Junos Node Slicing Learning Byte. All right, so you might ask yourself, what are AF interfaces? Well, it stands first for, the AF part stands for Abstract Fabric. And basically what that is, that's going to be a pseudo interface that facilitates traffic between guest network functions or GNFs. And it does that through the fabric of the actual BSys, which is of course the MX chassis in the node slicing setup. So this helps alleviate a problem of using a physical interface to route traffic between GNFs. All right, so let's go ahead and get to the example. A couple of GNFs here. We have GNF-A and GNF-B, which are going to be acting as PE1 and PE2 respectively. And then there's CE1 and CE2, which are connecting into those GNFs, and they're going to be forming an L3 VPN between the CE1 and CE2 devices. And so what we need to do here is we need to provide connectivity between CE1 and CE2. And as I mentioned earlier, we're going to be using an L3 VPN. This L3 VPN is mostly set up. We have BGP, we have Ospf, we have VRF routing instances and things like that. However, we still need to configure the AF interfaces on the GNFs and on the BSys as well. And then we need to configure the supporting parameters for the AF interfaces, such as the family INET. We're going to put an IP address on it, and the MPLS family protocol on the actual AF interfaces. And then we'll need to configure the AF interface to participate in the different protocols like BGP, Ospf, Ldp, MPLS. Now note with BGP, if you're familiar with how BGP is configured, we're not going to be putting the AF interface in BGP. However, we will be forming a BGP session through the AF interface. So I'll show you when we get to that what I mean with that. And the other thing to point out here is that we are using Ospf for the IGP. We could use ISIS, that would be fine. And we are using Ldp for the MPLS signaling protocol. We could use RSVP instead. That would work fine. That's not a problem here. Okay, so let's go ahead and jump to the CLI and let's get started on this. All right, so here is the CLI. We have GNF-A, GNF-B, and the BSys. And also we have the host device. Now the host device is a Junos device that is going to be acting as the hosts that are connected to the CE devices. And how we do this is split up into different routing instances. And so that allows us to act or have this host device act as multiple different devices. All right, so in GNF-A, let's go ahead and jump into configuration mode. We can look at the interfaces. We can see here that we don't have the AF interface configured. So let's go ahead and start doing that. Configure the IPv4 address. And then we also need, since we're doing an L3 VPN, we need to set the family MPLS statement. So it's the MPLS protocol family on the interface. And then we need to, actually before we do that, I'm going to jump to GNF-B and do the same thing. See here, it's not configured as well. And then I'm going to jump to the protocols. We do need to configure some protocols. And here we currently have some protocols configured. We have we have BGP configured. And it's configured to set up to work with pass routes with just straight up unicast INET routes and also L3 VPN unicast routes. And so I've pre-configured that. The local address is the loopback interface for GNF-A, and the remote address, the neighbor address, is the loopback interface for GNF-B. With BGP already being configured, we're not going to have to set that up, and it's supposed to happen. These loopback addresses need to be reachable through the AF0 interface. And then we have Ospf. That's pre-configured with the loopback interface, so that'll get passed through Ospf once we have Ospf set up on the AF0 interface. So to begin, let's configure Ospf to use the AF0 interface. And then we also need to configure MPLS. I'm just going to say interfaces all to just make it quick. Then we need to configure a signaling protocol for MPLS. We're going to use Ldp here. And so here's the configuration. Everything looks good there. So we go ahead and commit that. Let's jump to GNF-B. Jump into protocols. We got the same thing here. BGP is pre-configured. Ospf is mostly pre-configured. Put the AF0 interface in Ospf. And then we're going to use LDP again. And MPLS. Need to set that up. Let's go ahead and commit that. Exit configuration on GNFA. Okay, so that's committed. So let's look at AF0, and we get an error. The device is not found. Now, I did this on purpose because I do want to point out that we haven't configured the AF pairing on the BSys. So we need to go do that. So here's the BSys. Jump into configuration. Go under chassis network slices, guest network functions. And we can see here we have GNF1 and GNF2 configured, but we don't have anything set for the AF interface pairing. So with GNF1, we need to set AF0, which is going to be the local interface, the local AF interface for that GNF. Set the peer GNF ID to 2, because it's pairing with GNF1 to GNF2. And then we have to set the peer GNF AF interface. Then we need to do the reverse here. So the ID to 1, the peer GNF ID to 1, and the peer AF interface to AF0. Now you might be asking yourself, like, okay, we just said AF0 goes to AF0. That might seem a little strange. And the thing is, you can have AF0 on GNF, on a GNF, and then on the peer GNF, have AF0 as well. That connects just fine. And so it's perfectly legitimate if we wanted to configure AF0 on GNF1, which would be GNFA, GNF with an ID of 1, and with AF1 for the GNF with an ID of 2, which is GNFB in our scenario. That's completely legitimate as well. Just keep that in mind. You're not bound to keeping the AF interface numbers the same between GNF pairs. So let's go ahead and commit that. And you see a little warning message here, and that's okay. The reason behind this is I'm only using one routing engine. It's a lab setup. In a production scenario, you definitely want to use two routing engines in the BSys. So keep that in mind. Okay, so let's go ahead and jump back to GNF, and let's take a look. And fantastic, we have an AF0 interface showing up. Perfect. GNFB, same thing. Perfect. So let's go ahead and ping the other side. And great, that's what we want to see. We're able to ping the remote AF side, so the peer AF on the peer GNF. And so let's go ahead and check status of OSPF neighbors. Great, we have a full status. State is in full, that is, for OSPF across the AF0 interface. That's fantastic. And we can check on the other side. And yep, same thing. Everything looks great. And so the next thing to check would be BGP. And BGP has come up. That's fantastic. Although we do seem to have a problem. Looks like some routes are being hidden that shouldn't be hidden. So let's go ahead and troubleshoot this a little further. There was one thing that I left out on purpose, and so we will run through a few troubleshooting steps to help decipher this. So let's first check out the LDP interfaces. Oops. We can see we have, okay, loopback and AF0, perfect. And okay, so here we have AF0, it's in the up state with MPLS. Great, great. That should be, that's what we should see. Look at the Ldp session. We don't have any sessions. I think there might be a problem with forming Ldp here. Let's jump to GNFB. I do want to show one other thing real quick on GNFA. Okay, so we have INET and MPLS configured here. Great. So let's run through those same steps on GNFB. And notice how we only have the loopback interface here. This kind of leads me to believe we had a configuration problem. MPLS interface, look at that, AF0 shows down. Okay, so let's get another command. No Ldp sessions. Okay, so lastly, we'll see the problem with this command. You might have seen it earlier as well, if you were paying attention. Notice how the protocol family for MPLS is not present. So we do need to jump into interfaces and add that to the AF0 interface, the MPLS protocol. Okay, so that should definitely solve our issue there. Let's go ahead and jump back here. Oops. BGP summary, fantastic. We're actually getting those routes now. We're getting, a route. We're seeing that over the BGP session. These routes, there's 2 routes before we had, like we scroll back up, before we had no routes showing up in the BGP L3 VPN.0 or the CE-1.inet.0 tables. Now we're having 2 routes show up in the BGP L3 VPN and 1 route showing up in the CE-1.inet.0 routing tables for the 10.111.111.2 session that's going over that AF0 interface. So let's actually look at those routes. So there's a few things I do want to point out here. Let's first look at that the CE1.inet.0 table. I want to point out the 192.168.1.0/24 route. This route is the route for the CE2 hosts. We can see that it's learned through BGP. The next hop is through AF0, perfect, and we're pushing label 299904. That's great. That's what we want to see. We want to see that label being pushed. It's reachable through AF0. And then if we look at the BGP L3 VPN.0 table, we can see the 10.222.222.2:192.168.1.0/24. That's the corresponding route in that table for the 192.168.0/24 route in the other table we were discussing. We can see here that's basically got the same information. We can see where we're getting it from, where it's going to through AF0, and we're getting that same label pushed on top of it. So that's perfect. That's what we want to see. So let's go ahead and jump to the host device and let's see if we can reach. We're going to ping a host address from the CE1 routing instance. And perfect, we can reach it. So that's going through that L3 VPN, going over the AF0 interface. So let's add a bit more traffic on the line. And then let's jump back and look at some outputs. Okay, the first thing I want to look at is the Ldp session. We can see we have a session with 10.111.111.2 that is operational. That's perfect. That's what we want to see. And then we show LDP interface. That AF0 interface shows a neighbor count of 1. Perfect. That's happening right over that AF0 interface. We do show MPLS interface. We see the AF0 interface is up. That's great. And then let's go ahead and look at the AF0 interface output. And there's a few different things that are very important to see here, or that I do want to point out. First of all, I want to point out the input rate and output rate field. We can see here that we do have traffic going out of and into this AF0 interface. Now remember, it's coming from CE1 to GNFA to GNFB to CE2. That's the path of the traffic. And it shows, you may notice that it shows a symmetrical amount of traffic going back and forth. And the reason behind that is because we're using ping. That's how ping works. You're going to be sending traffic and receiving the same amount. If this was a production environment, there would be some asymmetrical traffic there for sure. And then the bandwidth field I want to point out, notice how it shows 80 gigabits per second. Well, that relates directly to the peer GNF forwarding element view output. And what this is, I want to talk about the peer GNF forwarding element view. And what this is what the local GNF views the forwarding elements on the peer. So this is GNF-A's view of what GNF-B looks like with its forwarding elements. And those forwarding elements are basically the FBCs and the PFEs that are assigned to the GNF. So in this example, the FBC slot :FE number shows us 5:0. And what that is, that's FPC5 and PFE0, or forwarding element 0, or it's the PFE, the packet forwarding engine 0. And that packet forwarding engine, that forwarding element, has a bandwidth of 80 gigabits per second. It also shows a status of up, which is important because if it shows down, that means you can't forward traffic to the GNF if it's down over that AF0 interface. So keep that in mind. And so, because I do want to show you that if we do show interface terse GE, we can see that we're using FPC4 here. We got GIGI4000. And so if we were to jump to the reverse side, do the same thing, we can see we're using GIGI500 here. And so I'm going to do that output again. And so that's why you see that FPC slot as 5 in this output. This is what the remote side is showing. Oh, I also do want to point out here before we jump back to the GNFB is that the peer GNF ID of 2 tells you what the peer GNF ID is. Now, this might kind of seem like, well, duh, we only have 2 GNFs. Obviously, it's 2 But you could have 10 GNFs paired together through AF interfaces in a full mesh topology like this. That might actually kind of be a little more difficult to, keep in your head which AF interface is going to which GNF. And so this is a great, simple way to check that. We can check the peer GNF ID for the AF interface. We can see exactly what peer it's going to. Okay, so let's go ahead and jump to GNFB. Look at the AF0 interface, and you can see pretty much a mirror of what we saw on the other side. We see peer GNF ID of 1. That's great. That's what the peer GNF ID is. But notice how we see bandwidth of 130 gigabits per second. Now, that might seem a little strange, like, whoa, the bandwidth is different, and the reason behind that is if we look at the peer GNF forwarding element view, we can see that the forwarding element bandwidth, the FE bandwidth, which is in gigabits per second, is 130. So the PFE, which is the forwarding element in GNFA, can actually do more than what the current GNF, or excuse me, the current PFE and GNFB can do. And so there's a little bit of a mismatch there, which means that we're going to only be able to forward 80 gigabits per second of bandwidth through this AF interface. And so keep that in mind as you do this. And the other thing I do want to point out is that you can have multiple items in the FPC slot :FE num filled. You could have, because the reason why I'm only showing one here is, first of all, I'm only assigning one FPC to each GNF. And then I only have one interface plugged in to that FPC. So I only have one interface enabled, one interface plugged in. If I had multiple interfaces plugged in this scenario, we would have more, and multiple FPCs online, you'd have more information under here. And so we could have FPC slot 4:1, which would give us some more FE bandwidth here under the peer GNF forwarding element field. And that would give us more available bandwidth as far as that peer is concerned. The thing to keep in mind is if we had two forwarding elements here, each that showed 130 for the gigabits per second, then the bandwidth field that you see that shows 130 gigabits per second would actually show 260 gigabits per second. So it's has a cumulative effect here where it takes the aggregate of all the forwarding elements available in the peer GNF and puts it in the bandwidth field. So keep that in mind as you're looking at this output. So that brings us to the end of this Learning Byte. We discussed AF interfaces and Junos Node Slicing, and we demonstrated how to configure and monitor AF interfaces. So as always, thanks for watching.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Network's certification program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.